So welcome to integration by parts, a new technique for integration. Our last technique was integration by substitution. This is integration by parts. And it starts, or it's founded, on the idea that we know how to take the derivative of two functions being multiplied. This is the product rule, f prime g plus g prime f. And the question is, well, what happens if we integrate both sides of this? If you integrate the derivative, well, when you integrate this, you just get back what you started with, f of x times g of x. When you integrate this, you get the integral of the first piece plus the integral of the second piece. Let's move this integral to the other side. So the integral of f times g primed is equal to f times g, subtract the integral of g times f primed. Or we write this, and the way I have this memorized, is the integral of u times the derivative of v is equal to uv minus v times the derivative of u. So let's look at how this works. Our first example, the integral of x sine x. While you practice this, what you get good at is choosing the two pieces. Let u be x, and let dv be sine x dx. So those are the two parts of the integral I was given. The derivative of u is dx, and if this is dv, then I have to integrate it to get v. The integral of v is negative cos x. So the integral of x sine x dx, that's u dv, is equal to uv minus the integral of v du. So that's x times negative cos x, subtract the integral of negative cos x dx. Let's rewrite that. That's negative x cos x, negative negative, plus integral of cos x. Okay, so we've integrated by parts, and what you'll notice is whenever you integrate by parts, you get a new integral. Well, if I'm trying to integrate, why would I want a new integral? Well, this new integral is easy. This integral was not. So what I was looking for to tell me that I was integrating by parts was if I differentiated part, right? If I took this x and differentiated it and integrated the other part, that would make an easier integral than the integral I started with. And there's the answer. And if I want to check that I have the answer right, I will take the derivative. I'm going to take the derivative, and then I'm going to cross it out because I don't have space here. So the derivative of this would be negative 1 times cos x plus negative x times negative sine x plus cos x. That cancels that, and the other two terms give me back the question, which is what I want. So my check proves I got it right. So that's integration by parts. What you get good at is choosing the parts and recognizing when a question is an integration by parts question. So I'm going to skip to question C here because question C is obviously, to my eye, integration by parts, because I can see that if I differentiate x squared, it's going to disappear. So I'm going to let u be x squared, and the derivative, now the integral of e to the x is e to the x. So this integral becomes uv u v minus the integral of v du. Okay. Better, but not done. So I'm going to do integration by parts again. I could have factored the 2 out of the integral. So I have the part I already got, x squared e to the x minus, whoops, I got it, I need the other parts here, du is 2, and I don't want dx in there. Okay. Okay. So the integral of e to the x 2x, that's u dv, and it's going to be uv u v minus the integral of v du. And now that integral, I can factor the 2 out of it. That's the integral of e to the x. That's easy. So this integral is x squared e to the x minus 2x e to the x. Negative negative makes this positive, and the integral of 2e to the x is 2e to the x plus c. I could have gone plus c all the way through on each integral, but then you have just a bunch of constants all being added that make a constant. Just plus c at the end. That's the integral. Now let's check it. Let's just make sure here. So this is e to the x. The derivative of this should give me back the question. So f primed g plus g primed f. Okay, let's factor e to the x out, and I get x squared minus 2x plus 2 plus 2x minus 2. That 2x cancels that 2x, that 2 cancels that 2, and I'm left with e to the x, x squared, which is the question. So I have integrated it correctly. So there's integration by parts. So it is an obvious choice when you see something that if I differentiated that part and integrated that part, it would give me a new integral that is easier than the integral I started with. Now, these next 2 questions are not obvious that they work by parts, but after you've seen them, you know they are. So I don't see big choices here. I need to pick something that I'm going to differentiate and something that I'm going to integrate. So I choose ln x to be u and dv to be dx. The derivative of ln x is 1 over x dx. The integral of dx is just x. And if you want to, you can rewrite the formula. U dv integrated is uv minus integral v du. So this integral is equal to u times v minus the integral of v du. And maybe you can see now why this is a common technique for integration logarithms, because when you have this ln, its derivative will combine nicely with other x's and give you something easy to integrate. So this is x ln x minus, well, that's just the integral of 1. And if you feel like checking it, you can. Take the derivative and make sure the derivative of that is ln x. So ln x, not obviously integration by parts. Arctan, question D here, is also not obviously integration by parts. But all the inverse trig functions can be integrated by parts. And again, if I'm going to do parts for this, and I don't see, there's only two things here. Let the first thing, I'll call it arctan x. And the other piece is dx. Well, the derivative of arctan x, I remember. And the integral of dx is just x. So, the integral is equal to u times v minus the integral of v du. And you ask yourself, is this new integral easier than the integral I started with? If it's not, then integration by parts is not a good idea. So what makes this new integral any better than the old one? Well, there's an obvious substitution. And the obvious substitution is for 1 plus x squared. And why is that an obvious substitution? Because its derivative is the top of the fraction. And maybe I shouldn't use the letter u over and over, but I'm gonna. You can't stop me. Let me erase my check from the question before. And so this becomes x arctan x minus x dx gets replaced with 1/2 du, and that's 1 over u. And the integral of 1 over u is ln u, ln absolute value u. Technically, these absolute values are unnecessary because 1 plus x squared has to be positive, but I'm going to include them. So integration by parts. We use it to integrate ln, we use it to integrate the inverse tan functions, and we use it to integrate anything where we can see that differentiating one part of the product and integrating the other part of the product will lead us to an easier integral than the integral we started with. What follows is some examples, and I'm going to ask you to try them for practice. One of them uses substitution by itself. All the others use integration by parts. I'm going to put two documents up on Schoology, one called Hints and one called Solutions. The Hints one tells you if I'm going to use parts or substitution, and if I use parts, how I'm going to choose which one is u and which one is dv. That's something you get better at with practice. Try these. If you're stuck, look at the hints. If the hints don't help you, look at the solutions. Try these, and then move on to the practice.